Thanks a lot. I would like to invite all 4 speakers here on the stage so we can do a little discussion and see if we have some questions from the floor. So if we would want to make a very short, simple description of blockchain, then it would probably be, I think what I heard Sönke say, whatever a trusted third party can do now is what a blockchain can do. So it basically means what you now leave to a trusted party, be it bankers or notaries or maybe publishers, we could also put it in a blockchain and then we trust it to computers. But why would we trust computers better than human beings? Sönke, I see you want to say something.
I sorry that I did it this way. I said I want to express in the way that blockchain can't do anything that a perfectly trusted third party couldn't be doing. In blockchain world, we have serious scalability issues. But if transaction or changes to a database that are of high value, where a lot is at stake, like for example monetary value or research data with a high impact, we could very well use blockchain for this. Yeah. So if there will be a blockchain application in the future. Sorry for this new abstraction now.
Yeah.
But like other things, like where a lot of transactions need to be done that are like of very little value, like let's say the amount of likes in a database, like how many downloads have we done, there would be a trusted third party. It would still only be the only solution. Even like we don't have a decentralized Facebook yet, and this is for a reason. Because there's like Facebook, there are so many transactions, and they have very little value, monetary value, but blockchain couldn't be doing this, yeah, because it's limited in terms of the scalability, yeah. So is it? Sorry.
Yeah.
Okay.
But I wanted to have one thing clear.
Yeah.
You mentioned scalability.
Yeah.
And is scalability solved in blockchain or not? Because I also read that scalability is even a problem in blockchain.
This is a fundamentally proven, actually physically proven theorem, the so-called Bohr theorem, CAP theorem, that you can only have 3 things of this triangle, and that shows that in distributed, decentralized systems, you can't have the full performance as in like centralized systems. Yeah, and this is
there is a performance issue.
It's a performance issue, and this is nothing new. There are a lot of like projects that are going on in like Ethereum. We call it sharding and all this, but they never solve this problem really. They say like we have like new regions where we have like this amount of transactions, but they didn't really solve it. It's all marketing speech, I'm saying at the moment.
Yeah. I see Lambert nodding. What is your view on the scalability and the performance issue?
Sönke explained it very well. I may only add one detail about this. This is a pragmatic reason for splitting the issues of taking care of objects, larger objects, which I mentioned before, and this valuable metadata trail, as I would call it, because this is the metadata itself is something where the scalability is not that much of an issue, while you need a kind of a separate but similar solution for larger objects like articles and so on and data sets.
So does that basically mean that the blockchain might be fit and suitable for the metadata, but not for the real stuff? I heard somebody say yesterday, if we live in an open science world, you would want to put all the research outputs, whether it's publications, data, software, you would all want to put it on one platform, but that would probably bust the pipes, no? That would be too much for a blockchain.
Let me put it a little bit another way. We urgently need for researchers a world where you can get hold of millions of objects with one click of a mouse and least of effort. This is really an important issue that we maybe don't care enough about right now. And this is something where blockchain not necessarily is part of the solution, but you have this different set of, I would name them advanced peer-to-peer architectures, which allow that to happen. And we need both parts.
Let's go to Joris. Joris, you mentioned that you had more than 50 submissions for the grant, the blockchain grant that Digital Science is offering. It only just closed, the submission period, so I guess you haven't studied them in detail, but I'm sure that we can build a nice session next year at this conference with the most promising startups there. But could you give some hints on what kind of peer-to-peer solutions are proposed there?
Well, I think they are a nice reflection of the three main topics that we discussed. So the cryptocurrency and a way to incentivize our audience in a different way. I think that's a very important one. Peer review is definitely one of the main challenges that people see, and solutions were made for that. Another one is, I think the most important, my favorite slide is your slide with the transparency and how blockchain could make things more transparent and more open. I think that's the second category, is that indeed the metadata around the whole process, the data trail of getting to the article, which again would solve persistent problems around reproducibility. I think those two ones were the main. But end of January we'll come with the final winner.
Yeah. Okay, we'll follow it. Yeah. And Evelien, I have a question to you, because you offer one of these applications and services. I was wondering how many of the people in that network, the reporters and the journalists, do they actually realize that this is done on a blockchain technology? Because blockchain is just a technology behind an application. So, I mean, does it make it more sexy for them? Does it matter anything?
Yeah, we write the hyperwave, yes.
So
we say blockchain, and then everybody's like, oh, I want to use it. No.
Yeah? And all these journalists think they'll be rich by bitcoins now, or something like that.
No, we take a slightly different approach than some of the other startups looking into blockchain technology. We really think about the business processes. So, as you saw in my slide, the example, you upload content as you are used to upload your content, and then you just press update, and that's it. You wouldn't notice that there's a blockchain behind it. And of course, for this first implementation, it is not needed to use a blockchain. You could use a general database for it. But our vision is the reusability of content. And for that end vision we have, there the blockchain kicks in. But you don't need to know that there's a blockchain behind it. And I think that's very interesting.
Yeah. Okay. We have a few more minutes for questions from the room. Oh, yeah, there are many. Please. Here's a mic coming.
Georg Botz from Max Planck Society. Blockchain needs a possibly big computing infrastructure, a distributed one, a shared one. Who is paying to operate this infrastructure? If it's a shared one, what's the business model for this?
Evelien.
Yeah, I can respond on that. So the blockchain system works with the nodes holding a copy of the blockchain, of the ledger. And a practical example how we use it is we provide the infrastructure, so we build code on top of the blockchain. And we provide the nodes to the publishers. So the publishers will run a node, and we can make some interesting economic models. Now our business models, we take a transaction fee whenever a call is being made to the blockchain backend, but we could play with these numbers, lowering these costs when you are a publisher running a node. And it's interesting for publishers to run a node. We want to build a publishing blockchain network because it is decentralized. So even we as a startup company are not defining the rules of how content is being distributed. We want to have a whole ecosystem participating in that and upfront agreeing on the rules how we play this game. And if people don't agree anymore, then can, for instance, split the network, which has been done already two times or three times with the Bitcoin network fork. So that's how we see it.
Okay, another question, Jean-Claude?
Yes, Hi, from the European Commission still, so Jean-Claude. So I think it's a very interesting session, and I think with blockchain, as far as I understand it, I see two issues and a huge opportunity. The issue is security. As far as I know, not one ICT system is secure. For the last 30 years, there is always someone who finds a way to breach it, and I'm quite sure it will happen here as well. But this being said, the scalability issue is very important, because there is a reason why the bitcoins are limited to 24 million, because the computer power you need in order to run your blockchain is so big that you can't make it bigger. And then think of the fact that if we are going to give up net neutrality, you will not escape the issue that you will have to pay somewhere for the costs of all this. And then the scheme becomes a little bit complicated. Now, I cannot say how realistic the projections are, but where I see an enormous opportunity for, and that's where we were thinking about blockchain in the context of the cloud, for blockchain is to secure the handling of data in a way that the producer of the data feels ownership and has ownership. Because if you imagine pumping up your health data, you know the example I gave yesterday, pumping up your health data across 28 member states, if you need enough, how to create a real trusted third party there, that's where I think the blockchain has an enormous potential. If it will substitute the editorial process, I'm not so sure, but in guaranteeing to a higher level what we are not able to guarantee today, data privacy, I think it has an enormous potential.
Jean-Claude, does that mean that the European open data cloud that you're creating, Science Cloud, yeah, should that be on a blockchain? So, if you don't Twitter me, if we want to find a way in Europe, and not in a hypothetical ideal paradise where there are not 28 member states, if we have to do it in a way that we create a seamless environment, I think we cannot escape, I personally think, not the Commission, that we cannot escape this kind of technology, because it is, as far as I know, the most secure and closest to the user as possible guarantee for data privacy. Okay. Yeah, Joris.
Yeah, just maybe about the costs of blockchain, because we all know the stories about the mining and the issues that Bitcoin has. This is not essential to blockchain, and there are different mechanisms to securing the blocks. And actually in academia, we have a unique infrastructure of university libraries and institutions that could help us with maintaining the database. Without having the mining and without having the issues that we see with Bitcoin. So I just wanted to separate those two things.
Lambert?
Yes. Maybe to give one concrete example for that, just another pointer to, and that is MaidSafe. It's spelled M-A-I-D, safe. They are since long around, and they have this interesting model that you dedicate some CPU time or bandwidth from your local machine to their network, and in exchange, you get the right to store some objects in a very redundant and secure way spread across the network, but you don't need to dedicate your computer's resources to a specific platform owner or a specific set of objects, but to the network in general. And there's this abstraction going on. And this kind of thinking and this will help to, I guess, to solve these kind of economic problems that you mentioned, and that's quite interesting. We should look further into that, and I'm really excited that you consider it, and I think you should reserve a certain space within the European Open Science Cloud to do at least some experimentation in this area, yes, and try something here, because this is a nice opportunity. Yeah.
Arnoud allows me one more question from the room, but it should be a short one, at least. Yes, here in front, please.
Hi there, I'm David Matthews from Times Higher Education. I might be about to reveal that I've completely misunderstood what you've all been saying, but I mean, in the research process, if you have a blockchain-based solution for monitoring all these different steps of the research process. Aren't there still some aspects to it where you do need a trusted third party to say something is or isn't the case? I mean, for example, authorship. You know, you might have some very eminent scientists put lots of data in, and then it goes through into a article eventually. But then some poor PhD student has actually done all the work. How do they get recognition for that? Don't you need a university or a journal or a department or something like that to say, actually, this is who did the work? You still need some kind of authority in that system to say what's fair and what actually happened.
I mean, if I got it right, this refers to the problems that the blockchain database can't like prove things about the real world, right? You need someone. This is like. This is the main author. This is the right experiment that we did. There's nobody forged with a microscope, and like this is like not solved. If somebody would solve this, I'm sure there will be 5 Nobel Prizes for this. Yeah, this would be really cool if the computer could prove something about the outside world, right? It's a big problem. People working on this. Yeah.
You still need someone, as part of the process, you know, to be designated as someone who says this is the key author, or
exactly,
yeah,
okay. or we did the experiment this way. Yeah. So we have like we don't get rid of trusted third parties. We have a lot of new trusted third parties.
Right. Okay.
Yeah, but maybe just because what you can prove is that a specific author uploaded the document. What you can prove is that the manuscript has been reviewed. What you can prove is that a reviewer with a certain identity has indeed done the review. So that is something you can establish by a blockchain, and much better than the way it's done with current technology.
Yeah. So garbage in is still garbage out, but
Yeah,
at least
exactly.
you know that the garbage was put in.
Very good.
Something like that.
I mean,
okay. I think we come to the end of the session, and now we have one more question to you, or at least I promised you to be back with some of the questions. You've now all heard of blockchain, and on the next question, I want a really honest answer. If you're back at your desk tomorrow and want to explain to your colleague in 1 minute what blockchain is, who can do that now? Oh, well, then we did achieve something. And then now the question, is blockchain a hype or the next big thing? Who thinks it's a hype? And is it the next big thing? Yeah, it can be, yeah, of course, you can say yes to both. But then, a little more precise, who thinks that blockchain will have really useful applications in 2 years, 5 years, or 10 years from now? 2 years from now? 5 years? 10 years? Okay, we stay tuned and come back next year. Thank you very much.